Welcome to July.
Welcome to July.
Welcome to July. How's summer treating everybody? Good. Everybody's got a mouthful of chicken.
Come on, we got Chicken Shack.
Just make noises. Okay, that's what I want to hear. To open, we have Kirk, who is going to blow our minds with science, and take it away.
All right.
Kirk is going to blow our minds with science.
You're not projecting that.
Yeah, we should probably project another screen.
I can do that, actually.
Why isn't your thing projected?
Because we plugged this in here. Called.
Oh wait, you have the wrong one.
No, I don't. That's not how it works. If that works, it's not. I swear to God, if that works. Well, yeah, we're setting up a loop. Okay, it works. I'm full of shit. Nope. Yes? Nope, it works.
All right, awesome.
Okay. I'm gonna try to make this full screen while you.
Come on, stream, where are you?
All right, so while Ryan is setting up, I'm sorry I didn't have HDMI on my laptop, and I see a VGA up there, but there's nowhere here there is a VGA cable. All right, so we just purchased this laptop, but it's already archaic, so sorry about that. All right, so what I'm going to be talking about today, I'm going to be talking about a whole bunch of nothing. All right? Pretty much, a whole bunch of nothing. All right. If you can see this glass, where is it?
No, it was good. It was good.
It was good?
It was good.
All right.
Yeah, you good.
It said, which one are you? Right? Are you half full or half empty? You're half full, right? Why would you say half full? Optimistic, all right? If you could see this, it says, the pessimists think of their glass as half empty. The optimistic person think of their glass as half full. But the other person is like, there's space for his vodka inside there. So in either case, he's gonna win, right? All right. So why do I talk about that? Recently, I've been seeing a lot of searches on my LinkedIn. And one of the things that I find out that everything that they're looking for on LinkedIn is being a full stack developer. Right? It's no longer a back-end developer. It's no longer just a front-end developer. They want a full stack. Right? So, well, how am I becoming full stack? That's the way I'm going to become full stack, right? but on a serious note though. Recently, I was just given an Angular project, and I had to take at least a week to learn Angular to get the project up and running. A week to do that. And it kind of reset my circuitry inside my brain and saying like, is it just being a back-end developer, is that just gonna make it, right? And I'm finding that, no, you have to be you have to be able to do everything. I would say, jack of all trade, master of all. That's what is not master of none, you have to be master of all now. And what's gonna make us go from where we are right now as our C# developers, we can't use C# developers anymore. We're gonna have to start using full stack. We're gonna have to start put all the good things. I see if you're not using Angular, people are not interested in looking at your resume anymore. So you have to have these things, and you have to know how to speak on it. Angular, React, all of these things that are now becoming the forefront, where mobile, desktop, all of these things are the things that employers want to inside their company. All right, but that's so much for that. I'm not that kind of person though, so I'm gonna put away that. I like to talk about code, right? And I like to do stuff with code. So inside my hand here, I have a Raspberry Pi, and it's running Windows 10 UWP and Windows 10 IoT Core, and it has a UWP application. So the purpose of this was I was trying to get this to talk to this brain pad that was given to me by Gary from GHI. I put this up I installed this last night. I didn't get time to do all the jargons like the PowerShell stuff. So what I did, I installed that application on my laptop. And here it is running. And if you can see, let me get close. Oh, let me see. Oh. Am I there yet? Am I there yet? Sorry guys, this is gonna be poor. But what happened here, can you guys see? Yeah, it's a brain pad, but look at this button about right here. Change this. So I'm actually losing signal. But what was supposed to happen is each time I hit this button, this is supposed to refresh. And how do I do that? I kind of Wi-Fi enable this brain pad using the ESP8266 chip. Real easy. I mean, once you get inside there, I will configure. You can do a lot of pretty cool stuff with it. And one of the stuff I also put on this is my daughter. She likes to play with my stuff. And I said, just press the middle button. But she likes to press all the buttons on this. So what I do to know that she's pressing the wrong button, I say, if she hits the right button, it makes this loud noise. And it gets louder, right? But then I can turn it off. So pretty cool. Some pretty cool stuff. And this chip right here is not just for, you can go on Arduino. So if you're in Arduino, you can put it on Arduino. And this same app, if you have it hooked up, you can also have it hooked up and send the same set of signal over from an Arduino. So it's not just for a .NET thing or anything. So you can have it hooked up to any of your Wi-Fi. The reason why I built this application is there are certain certificates that are required to talk to the internet. And nowadays, when the certificates are getting a lot larger, where we have to have 256 and up encryption, right? We have to, these small things don't have the space to actually hold those certificates anymore. So we have to build like a gateway for it first to talk to a local thing, and then that local thing that's big enough, whether you want to run it here on a laptop or you want to run it on a Raspberry Pi, you can do that. So the code, I also have the code up on GitHub. It won't show here, but if you want it, just see me and I can give you the code and you can go look at it, play with it, whatever you want, break it, I don't care. I got it somewhere else, you know, but do whatever you want with it. So, all right, so that's my talk.
Will you put it in the comments on Meetup?
Huh?
Yeah.
You can post the link to your Git.
Hi,
Okay.
gang. Everybody wave at the camera. You get chicken.
Yeah, I'm good.
You're a vegetarian, right?
Yeah.
Cool. We got vegetarian stuff. Did you get some?
I'm good.
Oh, okay. Let's. There we go. We'll just stare at the stickers on my laptop. Oh yeah, pro man. Take your time. Take your time.
No, I'm good. I'm good. I'm just taking all my belongings.
You don't have to stay here, but get out. Okay, so Derek, let's get you hooked up. So, theoretically, there's a bunch more chicken and potatoes and stuff if you guys want to grab some while we get set up over here. Is this yours? Well, I don't need that. The loud mic's not even working.
context on what the heck I'm going to talk about and kind of the situation I'm in, and potentially you can relate that to the apps that you're working on if it's relevant. If it's not, who cares? Okay, you got free food. If it's useful, talk about it, tell me I'm wrong, tell me I'm right, whatever the case may be. But I'm just going to kind of work a little bit with what I've been in and why it's relevant, or at least for me, the projects I'm working on. So about 3.5 years ago, I joined a startup, and we basically were starting from nothing. It was a greenfield project. We had a lot of existing knowledge about the domain that we were in from the people that were joining the group, this new startup, but we basically started with absolutely zero on day one. But everything I'm talking about was kind of more from being able to do this on a greenfield project, but this was something that's been culminating through various projects that I've been working on for the last, I don't know, 10, 15 years probably, which predominantly have been just existing applications, been running for a while. I work for a consulting company, so that's a lot of the stuff we did was just working on existing projects that were already out there. So this was kind of brand new, fresh, but like I said, whether you're working on something new, whether you're working on something existing, to me everything I'm talking about is still very relevant. So this is important, the kind of the tools that we were using, because it's not really .NET specific, although obviously everything in there, for the most part, kind of revolves around that, maybe not TypeScript, but we do have like a back-end HTTP API, primarily is in .NET and C#. We have your typical ASP.NET Core MVC app, we have a Xamarin app, we have a TypeScript app that's using the wonderful world of Angular. I say that with sarcasm. And then some native Windows apps too. So a lot of clients connecting basically to a single HTTP API using. So this thing is not in .NET Core yet, the API. It's actually running on 4.7 with like 5% of it is Web API, and then 95% of it is using Nancy. So a typical app that I find online, so I'm going to use one as an example, from like a Web API app or MVC, whatever the case may be. This is typically how I see the samples on docs on Microsoft.com, on GitHub, wherever, Code Project, wherever you're going to find samples at. And this is typical to, some of the apps that I've written that are specifically web apps. So authorization in MVC, obviously you can use the authorize attributes, you could roll your own, you can use identity server, that type of stuff. But some way, somehow, you're gonna, if you're creating an internal app, to some degree you're gonna have authorization. At least the apps I'm working in, they generally do. Data access, this goes from anywhere from using straight ADO.NET to using Entity Framework to something in between, like Dapper, or whatever the case may be. I'm always dealing with the database, data access, pretty typical. Validation, I mean more the surface level, pretty frivolous stuff. Does this look like an email address? Kind of validating a model coming in. Not domain specific, just not domain logic, just really just frivolous kind of surface level validation. And then the heart of everything I've ever worked on is the domain, is the business logic. Now, the thing that kills me with demo apps or the samples, generally, I'm not saying all across the board, but generally, all four of these are generally described in a controller, in MVC or whatever the case may be, even if you're using WPF or WinForms or whatever. But they're generally all bunched together, and if these are separated, they're separated in layers. That's the typical thing I see, is either they are a massive turd pile of controllers that have everything in them, or the other extreme of everything is broken down into various layers. So a data access layer generally, some business logic layer, some top level UI. I'd say more often than not though, when I was working for a consulting company, the layers were
Layers not required.
Layers not required. They were the 20%. The 80% was a mismatch of just various responsibilities. So I want to say maybe in the, I don't know, maybe like 10 years ago somewhere, there was this, I feel like a layer all the things approach to, at least in the .NET world. I think it's probably happening elsewhere as well, but there was this idea of just separating common things with technical concerns. So data access would live in one place. Business logic, you may have a separate place for that. Authentication, for the most part, if it's an MVC app or ASP.NET app, I generally see auth still living in the web app itself. It's generally not something separated. But I'm just going off of what I see in demo apps and projects that I've worked on. So, like I said, auth will generally live in ASP.NET for the most part. Does this look like something you've dealt with before?
Yes.
Generally? You don't probably want to admit if it's the turd pile one, right? But I'm assuming everybody has dealt with it at some point. So this is the world I was living in a lot. And most times, what's really interesting here is that we always started off with, hey, we're building a web app, and we're going to use ASP.NET. And it turned out most of the time that we weren't just building a web app. We were building more of an application that just had a web front end. So I'll just go through some of these layers and what I typically see in some of them. I mean, obviously your context might be slightly different, but you can probably get the gist here. So in the business logic area, there was usually a manager associated to any type of entity. So if you had a product, there was a product manager. If there was a shopping cart, there's like a shopping cart manager, customers, etc. And they were generally very, I'll call it cruddy in nature. However, they would have more behavior-specific methods in them. So you'll have your general add, update, delete there of a product. And maybe more often than not, there wasn't a lot of it, but there was more behavior-specific stuff like the increase and decrease inventory. But the key thing here is that product, like that type, that product type there, that would generally be a bucket. It's just a POCO. It has absolutely zero behavior in it, just a bunch of properties with getters and setters on them, generally. If there were, like any of the logic related to business logic, lived inside the actual implementations of these methods. But like I said, for the most part, well, I shouldn't say that. A lot of times, some of the rules and logic lived outside of this, potentially in MVC before it even called it. On the data access side, for the most part, there was your basic insert, update, delete stuff. And what overwhelmingly happened over time was a mirage of query methods. So like get by ID, your common one, maybe some get all active that really all it did was, so if it was using Entity Framework, it just selected all the products where active is true, whatever the case may be. Some simple ones, but then as time wore on, people realized, oh, well, I don't exactly want it this specific way. So then they would end up implementing some type of find method that had like that search keyword, some int, some page, and the list would keep going. We're to the point where there was probably one method that was re-implementing link at some point, right? Like they became overwhelmingly the number of query methods because you had to use this to actually get data out. So the thing that killed me with this idea of a layered approach was the sheer number of files, and especially if these were broken up into separate projects, like in Visual Studio, that you were jumping around to make a change. Felt completely absurd to me for the longest time. So if I'm just adding a simple property to the product model, I'd be jumping into the data access project, going to the product model, then finding the repository, finding the relevant methods that I may need to change, if that's applicable. Then going to the other project, like the business logic project, finding, again, the relevant files there, and then jumping actually to the web project and finding the relevant controllers, views, etc. that, were ultimately being used. To make a simple change, I'm jumping through 3 projects, through 5 easily numbers of files, I mean, Visual Studio and ReSharp are awesome, but it still sucks having to jump around and navigate through, you know what I mean, 5 different files. I found this incredibly painful for so long, and it's one of those things where I never really, like, when you have pain, you're like, something's wrong here. I never actually thought something was wrong. I kept thinking, like, this sucks, but, like, it never really dawned on me that this may actually be kind of a symptom of something, or something that just wasn't quite right with how I was working. So I've just grown into MVC. I was outside of the .NET world early in my career in the early 2000s. And MVC got popular kind of elsewhere beforehand, before like MVC like in .NET actually came out. But even back then in other languages and other frameworks, MVC by nature was always organized by controllers, models, and views. And I just find that really interesting. When you go file a new project, MVC today still, that's how files are organized. Why are they organized by technical concern would be my immediate kind of thought. I never really thought about it till several years ago, but that seemed natural to me. We always organize everything by technical concern. That's why we were organizing data access, business logic, what's even hiding inside of there. So, technical concerns, like this is the obvious one. Controllers, models, views, deep nested within there. Likely you'll end up having some services folder. What's a service? Nobody knows. Yeah, right? Like anything that you need to do stuff, just service. That's what I do. But it's just interesting, like this, I'm fairly sure this is exactly just me doing a file new in
ASP.NET Core, yeah.
Yeah, probably ASP.NET Core, because it's a startup file. This is the default. Obviously, there's different ways. I'll kind of show them how you can do it in ASP.NET Core, but I just always find this is really interesting that this is the default. So layered, clean architecture, layered approach. Has anybody seen this diagram before?
Yep.
Yeah. I'm with this. I can get down with this. This is good. I'm not saying this is a bad idea. I'm more so saying that organizing it this way really is the crux of my issue. So when I was talking about the MVC, a lot of the projects I worked on, they always started out as web apps, and very soon realizing over time that we actually didn't need to create a web app. We needed to create an app that had likely multiple ways to interface with it. One of them just happened to be HTTP. Likely because there's other things that we needed to do, such as just responding to different events that are occurring in the system. Something that we're going to have is kind of worker roles that are either whatever the case may be, but they're not going to be ASP.NET. They're not going to be a web app. So the first thing was, okay, if we have all this code in MVC to a certain degree, including auth, that's going to have all these attributes, how do we kind of decouple from MVC? So, like I said, in our typical thing here is we have a bunch of clients. In clients, I'm really more referring to our different client apps. So, like the TypeScript one's the browser. We have a Xamarin app, WinForm app, etc. That are just basically hitting our API. But there were other things that we needed to do, such as like scheduled and reoccurring jobs. And if you only have a web app, I guess the only way you do this is have some scheduled job or cron job running somewhere that's going to make an HTTP request. Like I've seen that a bunch of times, to make a request periodically, which seemed kind of silly because again, I just want to trigger something non-HTTP. I mean, I have certain actions I want to kind of invoke within the system. It's not HTTP. It has nothing to do with HTTP. So really, what I wanted to do was kind of create a common interface that represented a request within the system. So if you're thinking of HTTP, you're thinking of an HTTP request. It does something. You invoke MVC, translates that, invokes it, like your particular controller action. I kind of want to sit in between there. So something that I can invoke from HTTP, but something I can invoke from whatever else. Has anybody used something like Hangfire before? Know of it? So Hangfire is like a background, it's kind of like a background job client. that you can run separately in a web app. You could run it in a console app or a service, etc. But you still need you're not using HTTP at that point. So stuff that you want to run responding to events or in the background, etc. So we just want to cut like a common way of doing this that's not HTTP. So if I take our layered approach of auth, business logic, data access, this bothers me. I don't want to feel like have MVC calling one layer, calling the other layer, calling the other layer. I really want to think of smushing all those things together and thinking of them as one individual request. Just like you think of an HTTP request, you have a request coming in, it's going to do something. I just want to have the idea of I have a controller, I have something that's my I/O that I want to request something into the system. And I just want a uniform way of doing that, of making that request. And whatever that thing does internally, layered, or however you want to separate those concerns, we'll kind of get into that, but just like high level here, I just want a controller, something that's going to invoke something within my system. I don't want like the controller to be the app, I want that gray thing to be the app, basically. So back in probably about 2007-ish, I started getting into domain-driven design. Is anybody into domain-driven design? Yeah. So in that time, it was, I don't know how, I think it was just kind of natural that I also stumbled upon CQRS and event sourcing, and some of the other ideas that were going along with DDD at that time. And I fell victim to thinking CQRS was way more than what it was early on. I think it's one of those terms that has been, like many other terms in our industry, that is just misrepresented in a bunch of different ways. It's not as complicated as it seems to be. So this is Greg Young, who coined it with Udi Dahan. And Greg has a bunch of different quotes on this, but this is the best one, which is, it's really just the idea of having two objects instead of one for reads and writes. It's not about anything else other than that. He has an example, I should have included it, but he has the idea of like a banking service, and one's like get the statement, and one's like deposit money. Instead of those being two different classes, two different interfaces, separating those into, you have one class that's specifically for mutating state, and you have one class that's specifically for reading state. That's it. Nothing to do, that's as simple as it gets. It's really just an extension of CQS, which basically has that idea, but to the method level. So a method only changes state or returns state, never both. I mean, there's some exceptions to that rule, but that's generally the idea. So the reason why I fell victim to thinking it was way more than what it was at the very beginning was I'm picking on this code project article. The article itself wasn't that bad, but there was a lot of, like, if you search for CQRS, this diagram or a version of this diagram is probably the first thing you're going to see. Like on Google Images, the first like 100 images are a version of this in some way. So CQRS has nothing to, this is CQRS, but it has nothing to do with having a command bus. It has nothing to do with a domain model or using DDD or using aggregates. There's an event store down there with events that push events to an event bus, having two, like, and then there's a separate data store. None of that. That has not CQRS. CQRS is just strictly the idea that there's commands on one side and queries on the other. That's about it. So CQRS facilitates doing all this, but it's not that whole diagram of all those other things going on. So CQRS, it kind of allows the idea of having a request in a request response type way of defining either I want to fetch data or I want to mutate state. And I think of a request as individually having those layers. So stop, like, not necessarily thinking about layers application-wide or however you break down your applications, but thinking of them as to an individual request contains and owns those particular pieces of auth, business logic, and data access. So I'm going to throw out a few different patterns to accomplish all this. I'll explain them as we go, but there's really two, kind of three. The way I do this is with the mediator pattern. So the mediator pattern is just a way to predominantly used to decouple, but it's allowing you to basically have objects interact with each other, but not directly. So essentially, kind of thinking of it as having a middleman is how I kind of put it to people. So if object A has a dependency on object B, and it needs to call some method and needs to do something on object B, object A won't call object B directly. It won't have a reference to object B. If you're thinking about your class or your dependencies, it won't even have a reference to object B. What it will have is it will take a dependency on the mediator. And then the mediator understands how to invoke that other object. So if object A needs to call object B, it does it through the mediator. So I've written a few different implementations of this from project to project that I was working on. Jimmy Bogard, who is probably most popular library is AutoMapper. His second most popular library now is this. So I'm going to use it as the example because it's pretty good. Kind of fits the bill for everything that I need. So I highly recommend checking this out. It's gained a lot of traction over probably the last like 2 years. So everything I'm showing in the sample is with this particular library, but there's other implementations of this basically, but they all kind of work the same way. So what I decided to do was take the ASP.NET Core NBC Music Store app. So this was like the original one, but Microsoft actually did port it to Core. So I took that code and decided to kind of use this as the sample, if you will, of kind of converting this to use Mediator and CQRS. So that's basically what I'm going to show is kind of slicing features using CQRS with the Music Store app. So like this project that I have with the fork of this is on my GitHub. I'll post the link to that in the meetup comments. So the other pattern that's involved here with Mediator is the command pattern, which is essentially just encapsulating all the data you need for a request in an object. So if you were to think of a method signature and you have a bunch of parameters, pull all those parameters out, turn that into a class, and then you pass that, as your one parameter. What that does is it allows you to have, kind of like I was saying with the uniform interface, I can have one particular object that represents a request. So this is how Mediator works. Kind of similar ideas with the diagram I showed before is that what we're going to have is ASP.NET creating a request, sending it to the Mediator. The Mediator is going to take that request, instantiate whatever handler is responsible for dealing with that request, invoke it, and then if it's a query, it's going to return us the response. If it's a command, it won't do anything. We don't have a response. But basically, it's just passing along our actual individual request. So this is the index. So like on the home controller, this is like the main page that I was showing there that had a bunch of albums listed. So this is doing kind of what I said. It's doing some data access. It's doing some caching here as well. So a couple things is, I'll just go through some of it in case everybody's not too familiar with ASP.NET Core. There's the Music Store context at the top, the DB context, that's getting injected. And note the attribute from services. Is everybody familiar with this? From services? No? So the from services is the annotation, the attribute in ASP.NET Core to tell it that the DB context should be injected when that method is called. So instead of doing constructor injection, you're actually using, it actually does it in the method. So the same thing from with that iMemory cache. So it's basically fetching data, and then it ultimately uses the 6 albums to pass it to the Razor view. So the key thing here really is I only want MVC to do MVC stuff. I want it to do HTTP stuff. I want no part of it having any way involved with my actual code. So the simplest way to do this is, what is actually MVC doing here? I mean, obviously the routing for HTTP, sure, but inside this method, the only thing I actually care about it doing is the view, which is the Razor view. Everything else has zero to do with MVC. So I want to rip this code out, and we'll use mediator kind of request response to invoke this. So the first thing we need to do is create a request. So in this particular case, a request is pretty simple. It's the home. There was no parameters. There's nothing special we were doing there. So a request is simple as creating a class that implements iRequests, and then the type parameter there is just always, so the iRequest comes from mediator, and then your type parameter is what do you want as a result. In this case, our method, what it was doing was fetching out a list of albums, so that's what we're going to do. So we're just going to return a list of albums. So this one's simple because there's no parameters, but still, it's just that represents a request, a query. So then on the flip side, a request always has one handler. Not zero handlers, not many handlers, one handler. So it's fairly simple to create a handler. You basically implement iAsync request handler, and you have two type parameters. The first one is what's the actual request, the one we just made, which is home. And then second to that is what's the return of home, which was our list of albums. So what I've done here is like the body of that handle message, that's the only method you have to implement. And you can see it automatically takes our request there, our home query. I've 100% cut and paste the real body of that controller action into this handle method. In our constructor, I'm basically injecting the exact same things that I needed that we were getting from the controller. So I'm taking all our dependencies that we actually required here. If I jump back over to the index action, I can now strip out all those from services because I don't need the DB context, I don't need any of the caching stuff, so I have no injection here anymore. And I'm just basically in the constructor, I'm injecting mediator, and then I'm just creating a new instance of home and sending that along. That view model will be a list of albums, and then I can pass that to my view. So basically taking our code, separating it entirely. If you were thinking of that as like a separate, say you put that in a separate project, that project has zero dependencies on MVC, like none, which was pretty much the idea. So on the flip side, for a command to like mutate state, the example I took was adding an album to your shopping cart. So this is the shopping cart controller, and this is the add to cart method. So the same kind of process here is really what is MVC actually doing for us, kind of identifying those things and then working around them so I can strip everything else out. There's really three here. The type, or the parameter, the ID of the album, so that's coming from our route. The HTTP context, which clearly is from MVC. And then finally the redirect to action, which is going to be doing our, adds the location header and the status code. So those are kind of really the three pieces of information. Everything else is our stuff, fetching out the album, adding it to the shopping cart, etc. That shopping cart class, that static class there is another story, but just the idea of looking at the parameters, like looking at what's in the actual method, seeing what is actually used from MVC, and letting this code just be that. So for a command, for a request, this is where the command pattern comes in, right? So now we're saying, okay, there was a couple pieces of information we needed. We needed the card ID, we need the album ID. Those are really the two pieces of information that method needed. So this is kind of an example of the command pattern, is just creating a class that represents all the information we need to kind of perform our action. So if I jump over to the handler for this, so same idea is that I have a request handler. There's only one type parameter, which is the add to cart, because we're not returning anything. So I kind of condensed this. The constructor was doing the same thing as the other one. We were injecting what we needed. And then for the most part, that again is 100%, well, not 100%, it's almost the 100% cut and paste. The only difference is the get cart now takes the cart ID, which I'm passing through our message, through our request. And before that was using the HTTP context, which was coming from like the session, I think is what it was. So again, completely 100%, well not 100%, almost 100% a cut and paste. But again, now we have zero dependency on MVC here. So to get the cart ID, like I said, there's a get cart ID from HTTP context. Fairly certain in this example is using a session. And then we just create a new instance to add to cart, pass the cart ID, pass the album ID, which is coming from our route, and then doing our redirect action. So one of the key things here is that the dependencies for our database, et cetera, all our stuff is in our, like if you said, if you're creating that in a separate project, it's kind of living there. It has no dependency on MVC whatsoever. The interesting thing with this is that this, like those, where are we at? These from services, that the way that's injecting that. Anybody guess why you think they did this with having an attribute to define how to inject something? My take on it is because if you have a controller with, say, 10 methods on it, how many dependencies are you going to likely need? If you have to inject all of those into via like controller injection, what's the likelihood that every one of those dependencies you're going to need on every method? Probably not high. So to get around that, they created this attribute so you can inject dependencies specifically in the method that you actually need. The attributes just kill me. They bother me to no end. Okay, so in the command, there was one other thing that was a perfect example, which was the logging. So what does adding an album to the cart, logging, what does that exactly have to do with it? Zero. There's probably a couple different ways we could do this. And for me, the easiest way and kind of the benefit to thinking about Mediator is when I kind of showed the little boxes of having auth, data access, et cetera, in specific layers. We haven't got there yet, right? This is just, again, this is a separate concern for logging. How can we separate this? So Mediator has this idea of behaviors, which there's a couple different ways you can kind of think of them. So is anybody, how familiar are people with ASP.NET Core? Familiar enough? Okay, so how about middleware in ASP.NET Core? Okay, so the idea of middleware in ASP.NET Core is you have an HTTP request come in, and it goes through the first middleware, which then does whatever it needs to do. Then that subsequently calls the next middleware, and then it kind of traverses all the way back up, right? So I kind of think of it as like a pipeline. Another way to think of this is, I hate throwing out a ton of terms and patterns here, but another way of thinking of this is using the decorator pattern. So a bunch of different containers, like DI containers kind of can do this, like structure map can do it. But the idea of kind of having a chain, essentially, of things that you want to invoke. So I think of it just as a pipeline. That's kind of the best way I think of it, is having a request pipeline. So the idea being here is our callers like MVC, for example, we have our add to cart request, that's our command. But instead of just having that one method, that one handler that we're going to have, you can have essentially an unlimited number of pre-processor handlers and an unlimited number of post-processor handlers. So in our particular case, if you're thinking of things like auth, pre-processor handler. If you want to think of something like logging, in my particular case, post-processor handler, something that can happen after the fact. So that's exactly what I'm going to do in this example. Is I'm going to add something that's going to happen after our main method there, that main method handle method, and I'm going to add another class that's going to basically do our logging. So to do this is Mediator has this kind of built in, the version of it now. So I'm just going to create a new class that implements iRequest post processor. And these always have two type parameters. So the first one is the request that you're actually trying to accept. And then the second one is the result. So in the case of a command, we didn't have a result. We weren't returning everything. So Mediator uses it has a unit type, which is essentially, because there's no way to kind of define void. But this looks, for the most part, like the stuff we just created with our handler. But what we did now is we took the logger out of, and the logging out of our request handler and actually added in this post processor handler. So now we have one less dependency on that other handler. Now we're kind of really starting to segregate what responsibilities are through that request pipeline. So like I said, if you think of like validation, preprocessor, authorization, preprocessor, post-processor would be something like potentially like logging, maybe under certain circumstances. I'll use a real-world example that I use is that a handler for a query might basically build up some type of view model for a response, and depending on maybe who's requesting it or other information we pass in, we might mutate that along the way, kind of in post-processors. But it's really about kind of separating concerns through kind of the pipeline. So another way we could have done logging is through Mediator's notifications, which are basically an in-process pub sub. So you can create notifications, i.e. events, and send those to the Mediator. The Mediator will invoke 0 or many different handlers for that event. So we could have, in this particular case, said, hey, an album was added to a cart, and then subsequently pass that off to Mediator, and if there's a relevant handler for it, it would have done what it needed to do. So I could have created an album added to cart. It just implements iNotification. Kind of the command pattern here still, where I'm just saying, okay, what's the relevant data that a handler might need for this, which is in our case just our album ID. So it's pretty straightforward. And to create an event handler and notification handler, pretty much doing the exact same thing again. You're implementing iNotification handler of like what the type is, album added to cart, and then you just have to implement that handle method. So I just pretty much did the same thing as a post processor, just added my logger and did the logging there. And obviously this was taken out of the other handler. So there's a couple different ways depending on your scenario. Most beneficial for this is, I think because it's all in process, it's an easy way to start thinking about events and responding to events in your system and notifying other parts of your application, especially if it's all within a single web app. So it's kind of an easy way to kind of get into kind of event-driven stuff. So back to the wonderful world of layers. With the shopping cart, when I was working on it, making a change, I was going through the controller, the view model, there's the actual shopping cart model itself, the index. That is actually the screenshot of this project. And the thing that kind of, when I go back to layers, this being the default by technical concern, is if you were to look at that folder structure, can you actually tell what this app does? Yes, you can probably tell it's a e-commerce thing, but what specifically? What does it actually do? Like, what's the actual functionality? What are the use cases? Can you actually determine use cases from this thing? My answer is no. Like, yeah, I know there's an account, a home, whatever the heck that is, the shopping cart. So yeah, I can gauge that it's a shopping cart e-commerce system, but what functionality is related to the shopping cart? What's really interesting to that is then if you create another project, like how do you differ? If I created another shopping cart project, obviously they're not going to be the same. Obviously they're going to have different functionality, but the file structure would look identical. How is it that two apps that probably are vastly different relatively look the same in file structure? That kind of makes me feel a little weird. So if you organize by feature, what this looks like is And you can do this in, I'm positive you can do this in ASP.NET Core because I did it here. If you can do this in like Web API or like on Full Framework, the other MVC, I think there is a way to do this, but if I look at this structure and I look at shopping cart, my use case is I can add to the cart, I can remove to the cart. I mean, obviously this is really simplistic, but depending on what you had in here, you would start seeing actual use cases of things that you can actually do, that a user can actually do. Like, what are the actual features, the use cases? So the way that's structured is I generally have a features folder, and then subsequent to that is the area that it belongs to. So for example, the shopping cart, we have add to cart, remove cart, view cart. And the views actually live right alongside the view cart CS file. So no views folder, that's all nested down based on controller names, etc. You can do this now, like I said, you can create a kind of a view locator to tell MVC where to find the view. So there's no reason, it doesn't by default have to be in the root/views. You can kind of put it wherever you want. Like if you're just using by convention, that is. Models, I mean, those are still going to live separate because those are kind of cross-cutting things that a bunch of features are using. But this is generally, for the most part, how I structure things. So in the case of add to cart, for the most part, my controllers have one method in them, one actual action that has one route to it. And then subsequently to that, it has its command, it has the appropriate handler, and I added the notification album added to cart. And for the sake of just example, I also had the event handler in there and the logger. So, I mean, those are kind of duplicated because you'd only do it one way, obviously, but these are actually all in the same file. So if you're navigating to, hey, I need to do something to add to cart, guess where you're going? Add to cart. Control T, whatever it is, and I think that's the shortcut for finding a type. Add to cart. If you're going to features, add to cart, you're not jumping through projects, you're not jumping through files, you're going to one file. You'd be amazed when you look at commits on how the number of files are small. And I think the first reaction would be, oh, these files must be enormous. They're not. Like, they're actually still relatively small. This one's like 106 lines. So they don't really get out of hand, and it's very easy to start seeing functionality, and it's very easy to know to navigate code with essentially going into like one or two files, so assuming you have to do with like a model or something. So there's some things that you could kind of still keep in MVC. That, I guess this is really up to you. Is, like I said, authorization, and there's some validation stuff that you can do, like with model binding. I don't particularly like still using MVC for auth, particularly because, like I said, usually I have some other interface that's going to invoke a request. So usually I keep authorization out of MVC. The same thing with validation. For me, these are always end up being pre-handlers that kind of check whatever logic these things need to do. So the way we describe it all the time where I work is features. We just talk about features. We have some cross-cutting concerns, like maybe some shared models, which are usually pretty narrow. Maybe you have some shared validation to some degree. You're going to have cross-cutting stuff. But the idea being is that everything that is, I'll say, related, I guess, in terms of the actual feature, of the layers of the feature, stay together in the feature, generally in the same file. So I'm not saying, okay, you're going to completely 100% put everything in one file. You're still going to have some shared stuff. But for the most part, what kind of goes together stays together. So a single feature, like I said, in that file looks exactly like this. And I'll kind of give an example of how stuff's changed for us and what this enables. So a controller, like I said, for us, preprocessors, that's auth. Then it goes through some validation, potentially multiple validation handlers, depending on what it actually is. Then our main execution, and then, yeah, that's going to use some model or whatever the case may be. I do not separate into a separate data access layer at all. The only time that ever really happens is if we are creating an actual domain model and we'll have a repository for that domain model. That repository has one method on it called get by ID. That's it. All our queries have the query actually in the main handler. And the reason for it is because they're usually very specific for what they actually need to fetch, the data they need to get. And the immediate reaction I always get is, well, yeah, but we have these methods that a lot of other features or other code paths use, I guess. And for us, we don't. This has been kind of the way it's been for a long time now, is most actual queries need specific information and do it very specific, like in a very specific way. So having all these things separated might look like something like this. We have MVC, we have some policy-driven authorization. Maybe we're using Fluent validation at some other level, and then we're using entity framework in our main handler, and then we have our models, database, etc. Now, this is a legit thing that we constantly, well, I shouldn't say constantly, do often, is swap out some of these things with it, like these quote-unquote layers or handlers within a given feature. We switched from Web API to Nancy. So Nancy, if you're unfamiliar, is just another web framework. It kind of fit the bill better for us in terms of routing. We just liked it a little bit better. And in other scenarios, we switched from Entity Framework to Entity Framework Core on an individual feature basis. Most of the models, if you've ever migrated from EF6 to EF Core, you can pretty much identically use them. Depending on how crazy you get with EF, we don't. We pretty much use the minimal that we can with it. But there's other places where we don't use it at all, and we're just writing straight ADO.NET code, because that's where we need to optimize. That's where if you wanted to switch to Dapper. But allows you, instead of having to change, if you wanted to change, for example, EF to EF Core, and you're using some data access layer, you're replacing that entire data access layer. With this, you can slowly migrate because you're changing one feature at a time, essentially. So we do this quite frequently, and this has actually been really beneficial for us to move to ASP.NET Core, which we are slowly moving to, because we can actually change that top one from Nancy to ASP.NET Core. And that's how we're doing EF2.
This one single project or?
On this diagram?
Yeah.
So this would be a single feature
Inside it.
inside a project. So, I mean, for us, like, geez, there's like quite a few features inside a single project, but like when I was talking about a command or a query, to me that's potentially a single feature. If you need to add to a cart, that's a feature. You're adding to the cart. If you need to pull out a report, which any query really is, that's a feature. So like I said, for us, we kind of swap things out as we want to move forward with, say, EF is the big one, where we're slowly changing queries to use our new database context. So then the easy one that always comes up is services, and specifically microservices. I had the question, well, what does this have to do? Why didn't you use microservices? And to really distill it down is, again, to me, this more enables it than anything else. Because if you think of that gray box on the left as being one, I like think as services as kind of business components of like capabilities inside your app that have a particular responsibility, that have their own database. These things are autonomous. If you can define these boundaries, you don't have features calling other features anymore. You know what I mean? Like you don't have like this X service, whatever that service is, I mean from like a code service level, making a bunch of extra calls. So, and the idea here is that if you start doing this, you start creating features, you can start creating boundaries, especially the big one is really data and what data lives where. You can get to this. We do this now. We decided, hey, let's throw a cut line right down this line, and this thing is hosted separately from this thing. So to me, it's more of an enabler. The other enabler is kind of getting into messaging. So does anybody use any message brokers? Yeah? So there you go. So this was a useless talk. But the idea of like, once you kind of start using Mediator, you start using notifications. you can start seeing, hey, I'm doing all these things in process, why can't I do these out of process? Why can't I handle these messages outside? So whether you're using RabbitMQ, using Azure Service Bus, whatever the case may be, you can start thinking about, okay, offloading some of these requests or these notifications that other things need to happen either in your specific service still, your application, or whether you have multiple services that need to be aware of something happening within the system. You kind of start getting into this kind of an event-driven approach, which I think is it's just an easy way to get started. So you're not jumping to this immediately. You're not using something external. You're just doing everything in process. So it's kind of a gateway again. So the big thing for us is segregating our code from that top level I/O, whether that be MVC, whether it be, in our particular case, what's responding and ingesting the messages that we actually send to a message broker, and that's kind of passing things along. Using Mediator in process across integration boundaries, so obviously MVC is one of those. We don't control that. And async messaging, like I said, with events between services. That's kind of been a big thing of being able to kind of separate our application into specific boundaries based off data, but based off responsibilities, kind of like business responsibilities. And then feature slices, not layers, organizing things together that belong together, not by technical concern. The interesting thing when I started doing this with creating commands, handlers, etc., my first reaction was to create a commands project and to create a events project and still separate all these things by technical concern. And it wasn't until probably a few years after I was doing this, realizing, okay, like there's a command, it only has one handler, why are these things so far apart in terms of solution or project? So putting everything closer together, it's interesting too, because that is more of a thing that is done more so now in the front-end world. You'll see more and more stuff being put or close together rather than being separated by technical concern, which I find interesting, but we're still generally doing it by technical stuff. So things that you need to be aware of if you start doing this is because everything is using, Mediator uses a DI container, whichever one you supply to it. You don't know if you send a command, if you send some requests to Mediator and your code subsequently doesn't have a registration or doesn't actually have a handler for that message, you're not going to know about it till runtime, till actually you hit that code execution path and it's going to bomb saying, hey, like this, you don't actually have a handler for it. So in the case of my add to cart, if I didn't have that add to cart handler and I sent an add to cart, it's going to fail. So obviously test registrations, it's kind of the typical thing here. I actually kind of toyed with the idea, I've been thinking about this forever, is to create like a Roslyn analyzer that would look to see all the commands that you have, all the queries that you have, all those requests, and then just to validate whether you actually had the appropriate handler. I didn't do that. What I ultimately did was I actually just created a single unit test that does that already and just bombs when it fails if there's a missing handler. So, like I said, enablers, async, task queues, pub sub. The multiple data models and stores, that's when I think everybody gets hung up on CQRS saying, oh, I can now have a different data model for my read side and my write side. And yeah, you can. You don't need to. You can be using the same database. But when you start doing that, you start creating commands and queries, and potentially you start using events to let the system know that you have changed something with the system, that it can update the read side. That's when you can start getting into multiple models, and it becomes really useful in various places, but I wouldn't say start there, but it's an enabler. And the biggest one for me, I cannot stress this one enough, is that you now define dependencies per command or query, like per request. So like I was saying before, swapping out, okay, if I'm taking Entity Framework 6, a DB context here, what's stopping me for in that particular handler switching it with something else? Nothing, right? I don't have to introduce another dependency that's affecting everything else. It's just specifically to that particular request. So that one has been easily, by far, the biggest benefit to us, is being able to slowly migrate things like ASP.NET Core from the old one to the new one, EF, logging, as well as I'd say experimenting to a certain degree, being able to test something out in a very localized spot without having to commit to, hey, we're gonna kind of test something out over here that's not really in prod. Like, we can actually do this legit in prod and make a very specific test case that we want to test something out to see how it actually performs. So to me, that's the biggest one is dependencies and kind of having them segregated. And that is it. So I don't know if anybody has questions, whatnot.
How do you approach unhandled exceptions in your handlers?
So generally what we do is in MVC, we'll control it there, depending on where it's actually incoming from. So whatever's invoking it all the time, like say we're just for MVC, we like have a global exception handler there that deals with it. And depending on what exception it is, we return different things back to the client. So if it's something that we know that's a kind of our own created exception type, then we'll probably throw 400 with a particular message, like the body of that. But yeah, it's kind of done more there. If it's done from like a handler that's something that we brokered out to a message broker, that just ends up going into our failed queue, and we deal with it there separately.
I'm working on it.
Yep.
Oh shit, Jade sponsors here. I'm just gonna remove the website right there.
So, no. In our case, where we actually have real domain models, really what happens is we still use like preprocessor handlers for auth, for validation that is, like I said, the kind of the superficial stuff, like not real validation, business validation or logic, just the real superficial stuff. And then the main handler, generally what it does is it will take a dependency on like a repository, like I said, that has one method on it called getById, and that will give us back our actual domain object that will call the appropriate method on and pass whatever data. So it kind of depends what part of our app is. Like only certain parts of our app we actually have a legit domain model. Some parts are they're just kind of more CRUD. There's not too much behavior in them. So kind of the core parts that we use it on like a real domain model in, some parts we don't. But I can see the argument, and I had a discussion with somebody that said like this could lead to you not having a true domain model, which I can get behind. I just think you would just need to kind of really be thinking about that. Yeah, like you don't want to be putting everything in those handlers.
Question for you about your mediator. So it seems like you're going to have a dependency now on mediate R in your controller and other places.
Yep.
And that's going to do all of this magic.
Yep.
You kind of lost your what is my dependency. So like your handler, you're going to send this add to cart request.
Yep.
That's going to get you, or mediate R will get you an add to cart handler.
Mm-hmm.
I just realized that.
Well, it will invoke it for you, basically.
Right.
Yeah.
But I mean, so how do you know, how does the controller know that it's gonna, I don't know how that dependency is gonna be fulfilled, or what methods are available on that dependency? Versus like if you just had an I add to cart handler,
Oh, okay.
a class that you could now pull in
Sure.
the controller.
Yeah. Okay. So you could. Yeah, that's actually a really good point. You could actually, like, if you weren't doing this. So if you weren't using pre-processors and post-processors, 100%. If you weren't using those, I would argue don't even do this, because really you're making it more complicated, because you're almost kind of like at that point using a service locator to say, hey, invoke this thing for me and doing it once. So yeah, no, if you're only going to have one handler, like if you're going to have a single handler and not pre-processors, really the benefit that you get is once you kind of have that pipeline. So you could do this entirely without mediator if you took your injected the handler in your MVC, and then used, like I said, depending on what DI, like I use structure map a lot, so I know like you can configure it to use, it's called the decorator pattern, which essentially is this. So yeah, you can accomplish the same thing and just have that handler injected into your controller, basically. But yeah, if you weren't going to use any of the pre-processor, post-processor stuff, then yeah, don't bother using Mediator, because you just inject the requests to the class that you actually need, and there you go. Or the interface, I should.
Pre and post processor handlers, can you set what order they go in? Or is it
In Mediator, technically you can, because yeah, like it calls them behaviors because like it adds that interface that I was using, the preprocessor one. It kind of builds that in to simplify your life, but you can kind of create them yourself of what those preprocessors look like. So you could kind of create your own that you would define what order that they're going to be in. Yeah, so you can actually define how you want them to be in ultimately, which is, yeah, pretty useful. I mean, we do it because we do certain things in certain orders. Same thing with post processors, we do things in certain orders sometimes.
Do you have any generic component in your system? For example, generic repository for working with database or something like that? For encapsulating logic which you will repeat in each command, in each handler?
I don't think we do. I mean, I used to use a generic repository, and it slowly got dwindled away, basically, there just wasn't a need. Like, ultimately, we would use a generic repository to return some aggregate root, is ultimately what we would do. And it was just more, when we kind of wanted to mutate that thing a little bit, we realized that in particular context that we were in, we wanted that repository to be a little bit different and not the same. So the idea of a generic repository was like, we just blew it away and said, okay, implement this one get by ID, and however the heck you want to do that behind the scenes, be my guest.
So technically you repeat this code from one feature to another all the time?
What code?
I mean, fetching data by some specific rules.
Say that again, sorry?
Fetching data by some specific business rules. For example, searching by fields or pages or something like that.
Yeah, so when I was showing an actual individual feature, like could you have some repository that got out a fetch by some specific use case? Sure, that was used a bunch of times. I'm all for that. In our case, most of the times, is those particular queries, if we're using EF and link, they're not duplicated anywhere. Like a feature ends up being something very specific, like what the data that we select is. But yeah, by all means, if you have something that's very repetitive where you're writing the same query over and over again, I'm not advocating not doing that. By all means, go ahead and do that. I'd be more curious if you looked at some of the queries that you're making, like how common they are, or how, I'll give you an example. I don't know if this is a resharper feature, or if it's actually in Visual Studio now. I can go back here. So I think it's called Code Lens, which tells you like the number of references that are used. I'd be curious to look in your repositories and see how many of those, if you have a lot of queries in your repositories, how many of them you use in less than 3 places. And if they're not used in less than 3 places, are you fetching out an entire entity most of the time when you actually don't need to be fetching out an entire entity? Right? Like, are you fetching all this data and then the consumer of that thing uses one property on that entity? That's what I'd be really curious of.
Yeah, this makes sense.
Yeah.
Technically it depends from the case.
Yeah, like I said, my context, most of the time we're fetching very specific stuff, so stuff like this ended up being, oh, one reference. Somebody created a new method to fetch data, they just write a new method. So yeah. Yep.
So are you sort of an example of like splitting out your logging call?
Yeah.
Would you still do that if you needed that logging to happen in a transaction with your?
So what?
Say, I mean,
Yeah.
logging
So
might not be a great example, but something. where
No,
you
that's
have-
that's legit. Yeah, like if you in Mediator you can. So when we talked about like these pre-processor, I can find it again here. This one, you can actually kind of define that blue part. So you could actually have your pre-processor invoke the main handler, and that pre-processor would actually be the thing that starts the transaction, right? So you can actually kind of wrap that whole thing into one. So you have a bunch of handlers. Or not a bunch of handlers. You have one handler, maybe some other ones, but they're really wrapped in a transaction if you wanted to do that. Yeah, if you wanted like to make sure the logging happens. But it's a good point because the other thing, once you start doing this, if your post processors fail, and like throw an exception for whatever reason, invoked or not, like your whole thing's bombing, right? So stuff might have happened, like you might have actually added to the cart, but you never actually got logging because something happened. So yeah, you need to be well aware of like what's actually happening in those handlers, and then once you kind of get burned by that enough, that's when you start like, oh, let's use messaging and let's get these messages out of process and let them fail, so I can retry them later. That's why I say it's kind of like I like this as like a gateway, and then you start kind of feeling the pain of them failing in process, and then writing try catches all over the place. So, yeah, most of the time, everybody I've talked to afterwards, that's where they lead to, is start getting into using a message broker. But I think it's especially depending on the size of your app, even if you just got like small things that are going to fail, or like that you want to do after the fact, I think it's just because it's an easy way to kind of start breaking up some of the responsibilities. Yep.
Practically, doesn't it, in fact, be able to have different dependencies for each request? So I can see where you might really change this one, or change that one, but then maybe migrate to something else that would just open up.
Oh yeah, I can get behind that too. Yeah, like hey, we willy-nilly decide to change this one thing and that didn't work out, so then we start changing another one. Yeah, ultimately you could go down that road of like a mix mash of features using like no uniformity, where you're just using tech all over the place because Derek decided to experiment one day and start using something wild. I mean, it could totally happen. I guess, I don't know, that'd be more of your own team trying to figure that out. And then, yeah, just dealing with it, I guess, like not jumping the gun.
Feature means a business case, right?
Yeah.
That's how it should be.
Yeah, so for us, it's like it could be a single request, and sometimes it's actually a couple of them, depending on what it is. Like, we'll usually have a combination of things. We may actually have, I don't want to go too far in this, but we have like other things that I deal with. We call them process managers. Some people call them sagas. I think those are different things, but you can get the gist of that. So just things haven't happened in a particular order, kind of externally, maybe just not entirely in the same system. So yeah, like some for us, they may be one individual, like usually for the most part, like an individual query is usually, we view it as a feature. Anything that's going outbound that is going to be presented in some consuming way, that's going to give them data, we just think of it as a report, not as like a SSRS report, but anything that's going on screen, we just view it as a report. And generally, that ends up being a feature. Like we got to populate something somewhere, so see something. So. Yep.
How's the shared items folder segregated? And where do you know when it gets too big?
So shared stuff, like stuff that's kind of.
So you have your generic queries, things like that.
Yeah, I mean, how do you know when we're getting out of hand? Shared stuff.
I'm sure there's some point when there's too much.
Yeah.
That's not the point.
Yeah.
Do you just dump everything into one set of files, or are they all done by sort of like some semi-feature, or because you didn't really
Yeah, I mean, like the things that we generally have shared the most end up being validation handlers. Like there's a set of features that require like state change that generally, same thing as like auth, they'll be like, okay, this specific set of actions, user needs these particular roles or whatever the case may be, and that's common across like, say 5 or 6 of those things. And those just end up being just shared classes that we have that either we inherit off of or that we inject. But the way that kind of our project structures are kind of separated, like those just generally end up living in the same folder as those features. So like say it's, I don't know, like the shopping cart one, say there's some specific validation. In the shopping cart, that folder, we would have one called like validation.
And that would be in the base there, or?
Well, it'd be like in the feature folder of where it actually lived, like depending on what it was relevant to.
Right, but what if it was shared across two features?
Yeah, so like here. So like say it was, I mean like so that added cart's one thing, removed a cart is one thing. Let's say we had common validation between that. I would literally put it in that shopping cart folder.
Instead of just shared folder.
Yeah. What's that?
I see a shared folder.
That's what I'm asking.
Oh, not mine doing. That's like existing, the existing app.
That's what I was asking, because then
Yeah.
in such a case,
We don't have a shared folder.
okay.
Yeah,
But you're saying that some of the features are shared, so.
Well, I mean,
Validation.
certain very specific things would be shared that would be common to, like, say, a shopping cart, right? So, but not a shopping cart and the accounts, the users or something like that, generally. I mean, we probably do, but I don't know what it would be off the top of my head. Generally, the things just live in kind of in that folder related to that particular, like the shopping cart or users or products, whatever the case may be that you're dealing with.
For example, base.
Okay, good example. Yes, we actually do that often, depending in the context. Yeah.
I'm thinking a base entity or something else.
Yeah. I mean, validation. We've done it a couple different ways where we've actually kind of created some abstract-based class that has validation that we then inherit on all those other ones, like so the added cart, removed a cart, because the either will do exactly that and that plus something else, because it's not likely that each command is going to have the same properties, which is going to require the same validation. Like it'll have some set of the same validation, and then there's generally other stuff that needs to happen too, right? Like validating that the ID of the product that came in was legit a product, or whatever the case may be. Right, so that's generally how we do it. We've also tried just creating a separate class that we inject that has a bunch of validation on it that's reused, but I haven't really cared too much about one approach or the other. Cool. Thank you.
Okay, everybody yell goodbye.
Goodbye.